Welcome everybody. Today we're going to continue on with our doubly linked list lecture. We need to do deleting items in a middle. Note that deleting items in a middle has a little bit of applicability to your homework assignment, but this gets to go about it in a much easier and clearer way. Also, last time we covered shared pointers. The consensus of the class is that I think you guys like them better. Yeah, on one hand, you don't have to worry about saying delete every time, but on the other hand, it does long-term seem to clean up memory leaks, and a lot of you are getting a lot of memory leaks in your code. I've received a lot of emails. Sure enough, what was the one thing I said you shouldn't do when declaring a pointer? Declare a pointer and make a note at the same time, which I'm seeing a lot of you are still doing. Shared pointers can help with that, but of course you should just be programming the correct way to begin with. So I want to continue on with shared pointers today, and then I want to jump into a concept called iterators. They're a fundamental concept used in many different programming languages across many different kinds of containers. And it's important for us, in my opinion, to know them and to be able to create our own. Are there questions for me before we start? I would like to get a quiz out the door today, just so that we can, well, before I say that, how is that homework assignment coming for everyone? Who is done? 1, 2. Online students, who's done? 1. We have 3, almost there. Right, and Mike, we've been talking. Who has got at least everything except for delete all of occurrence?
Or delete all instances?
Yeah, delete all instances.
Yeah. It sucks.
That one's. Do we need to go over a strategy for solving that one?
Man, I thought I had a good strategy. That's the
You
problem.
know, it's blowing up on everybody. And that's a good real world program. You think, I know I can do this, but you try to debug and it doesn't work out. Let's talk about that. Also, just a heads up, I will be getting a quiz out the door today, due in a week. That's the quiz. You don't get credit till you do it perfectly. All right, let's pull up our OneNote here. I'll just scroll down. All right. So the idea is, if I had a bunch of nodes, and I'll do something like from the homework assignment. If I had all these nodes, and I'm just going to simplify so I don't have to draw nodes and pointers. Is that all right? Are you okay with the idea that those are all linked lists, nodes going one after the other? Of course, we have our linked list object with the front or first, and the back or last. I think in your homework assignment it's called front and back, so I will do the same. There is a count, but I'm going to do this without count. And if I were to say, all right, delete all instances and delete the 9s. Further, you can only march through the list once. You can't march through the list multiple times. You can't start over at front at any time when you're midway through it. Correct? So the tricky part here is, in my opinion, splitting this up into 3 chunks. And I have actually found that students who actually just do this, and how do I say it? If you try to solve it in one giant while loop, I find that to be tricky. And it seems to blow up code, and it seems to just be uglier. It can be done. It's not hard. I'm just saying for the easiest way that I think has the highest success would be to split it up into 3 different chunks. So the first chunk would be some while loop for when it's at the beginning, another while loop when it's in the middle somewhere, or anywhere, any groups in the middle, and actually, you know what, you can't really do while loops at the end because you don't really know is that at the end or not. So you really have to kind of merge middle and last together into its own scenario. Does that make sense? In other words, how could I know that this is a last group unless I do some pre-look, some pre-pass on it and verify, is that a group at the end? If you start here, do you know that that's a group at the end? No, you don't. So what we're going to do is we're just going to do the group at the beginning as one chunk, and then the rest of it as another chunk of code. Sound fair? Are you guys not liking this because it deviates from the way you did it already? Yep. Did all of you try to do it in one big while loop?
I did.
Is that how you guys solved it? Should we go back and do it that way?
I mean, this looks smarter.
Let's go back and do it as one big while loop then. So backing up then, if you want to, you could technically have one set of while loop that says while front's data matches what I'm looking for. And as long as that condition is true, just get rid of all your front nodes. Then you could go to a second while loop, which is basically saying while cur doesn't equal null pointer, while you're still making progress through the list. So if we were to do this as one giant, it is trickier, but the idea is that we want to say while cur doesn't equal null pointer. And we want to have a cur, and we also want to have a prev. Correct? Now when we get started, before we enter the while loop, we don't want to set cur to the second node and prev to the first node because we didn't check the first node. We do need to initialize cur to front, prev still at null pointer. Correct? Then we can ask the question, well, cur doesn't equal null pointer. Is it true that cur doesn't equal null pointer? Yes. So then you can ask the question, if cur's data, and what do I call it? What do you pass into your method? Is it value? Is it item? What's the name of yours? Value? If cur's data equals value, then you have found a node to delete. The next question is, where is it? You have to check all scenarios. And when checking scenarios, it's usually best to do specific first and general last. So what's the most specific scenario you can think of if we get to this point? There's even something more specific than that. A one node list. So I would do a scenario for a one node list. And one thing you have to remember to do in that scenario, when you're done, you should be updating cur and prev if needed. So when I get done doing the deleting stuff, obviously I leave that to you. You want to set cur equal to null pointer because there's nothing more you can do with it, correct? And that will ensure that when it comes back around, it will exit the while loop and you can be done. Now another really important thing you got to check for, this will be some kind of an if statement to check if it's a one node list. Please do not do a second if down below here for checking your next scenario, because it then, after you get done with this one, it might trip into this next one and it causes you all sorts of problems. Set that up as a else if. What's the next most specific scenario that would be appropriate to cover in here? We did a one node list. Which one would you cover next? It would obviously be two or more, but we know what matches. We know there's two or more. So now we have to check, is it at the beginning? At front. And so you have to write your code to manage that. Else, if you have to cover another scenario. What's another one that's specific? We've done one node, we've done at front. What else could it be? At the end. And if the node matches the value and it's not a one node list and it's not at the front and it's not at the end, then what must it be? Is there two more scenarios, or is there just one more scenario? Just one to go? So I can do that with a single else in the middle somewhere. Correct? And how do you handle the in the middle step? What should be the step-by-step process? For example, suppose cur is here and prev is there. Tell me a step-by-step process how you'd get rid of that 9. What would I do? Anybody? Prev's data? No. This is a sin. We have confession booths at the Ogden campus. You'll need to go visit them. The reason that's a bad idea is you don't want to copy data. Get that off there. Copying data is a very bad idea with linked lists. The whole point of linked lists is that you just get to move pointers around. Leave the data alone, but just rearrange how they link up. For example, what if your data was gigabytes in size? You don't want to make a copy of that. You just want to update a pointer. All right, you did mean link. I knew that. I was just giving you a hard time. So prev's link equals cur's link, which would do that, correct? All right, what would be your next step? Delete cur. Should it be delete square brackets or just delete? Just delete, it's not an array. All right, so you delete that node. Anything else that needs to be done? Here's where we're at. Decrement count. What else? Should cur still be pointing there? No, we need to make sure cur is updated so the next time the loop goes around, it's in a good spot. So how do I move cur to the correct spot? Just give it a little nudge. Just push it. What should cur be set to? Cur is equal to what? Cur equals prev's arrow link. We'll do it. This is a singly linked list because your homework assignment's a singly linked list. So cur equals previous's link. We'll do it. Now our linked list is in a good state so that it can wrap around and do the algorithm again in the while loop. So if you set up your code with this kind of a construct, while cur doesn't equal null pointer, and do scenario 1 node list, then scenario at front, scenario at end, scenario in the middle. If you do those 4 scenarios, you should be able to handle it. As always, do not make a node when you're making a pointer. Also, do not copy data. If you do those, you should be okay. Yes, Mike. Mike asked, so even though we delete cur, we can simply tell it to point somewhere later and it exists still again. Cur exists. When you delete cur, it's not actually getting rid of this guy. No. Even though you say delete cur, in your head you think, that's a natural reaction. Oh, I'm getting rid of that pointer. No. What are you getting rid of? You are getting rid of the thing that cur is, the address at cur. So I almost wish that it was called reclaim at this address instead of just delete. So when I say delete cur, it gets rid of that node, but it still has the address to where that node used to be in memory. And if I set cur is equal to prev's link, cur now has the address to this node. We never got rid of the pointer, we're just reusing the pointer.
So you can say delete this pointer, delete pointer.
But it doesn't delete the pointer.
But you can then use the pointer
Yes.
afterwards to ultimately. Okay.
Does that make sense? It's like if you were demolition crew, and you got an instruction, delete address. Oh, here, this road. Delete 500 Main Street. So you go to 500 Main Street and delete it. Did that actually get rid of your little piece of paper with the address on it? No. So now someone could go and update that and say, now delete 800 Main Street. Okay, you go delete that. That's all it is. Oops, let me get back here. Does that help with the delete all of occurrence? Does it give you some, is there anything you're still stuck on? You're wondering, how am I going to get that done? Please debug often. These assignments are near impossible to solve without using the debugger. It can be done, but my goodness, you're wasting your life. Learn how to step in, watch the code process, and also learn how to solve these things. How to just say, okay, what is my code doing? Draw it out. Watch your code in the debugger and say, oh, my code was doing this. It should be doing that. Too many of you are writing a real mess of code, and it gets so ugly that it's not just 1 or 2 bugs. It's 20 bugs, and you're trying to figure out how to salvage the thing. The way you salvage it is by starting over. I'm serious. You solve these things. Let me give you a good. This isn't. I don't have this published anywhere. I haven't thought this all the way through. But this is Brad Peterson's Guide for Problem Solving. You guys can add in your own approaches if you'd like. Write a few lines. Write 3 to 5 lines, then test it. What's the wrong side? If I were to have if this is the good, what's the this is the good, what's the wrong way to do it? What's the opposite of write the entire code and then don't try to test it, which too many of you do. Understand what you wrote. Now you're laughing, and this is a real problem. I see this all the time. I've been a math tutor. I'm an instructor here. I see when people write code, and a lot of times people just throw stuff out there, and they don't ask, what is it that I just put out? A lot of times it's because you copy and paste. I saw the instructor do this, so I'm going to throw this. Or I kind of have a vague idea what this line of code. I bet this is the right start. If you can't say what the line of code does that you just wrote, you need to go back and really ask, why is this % symbol here? Why is there an asterisk here? What's going on? Why is there a new in this line of code? What's that new doing? So of course the wrong way is just to copy and paste blindly. Yes?
So when you're doing like 3 to 5 lines at a time, is it still possible for the program to compile?
So obviously this isn't exact. Like if you write 6, you should just give up life. No, I mean, it's a general rule of thumb. You just solve a mini problem.
Like do your first if statement, then all the way up to the middle statement. Also.
Does that make sense? I should say, the reason I said 3 to 5 is I know if I say a few, some of you will think a few means 50. And I want you to get this idea that, yeah, really, you don't just write everything and then test it. You really just incrementally just, did this work? Or,
Yeah, like is it possible to debug like a certain part of the program without like I don't know, can you still compile even though you're doing 3 lines?
well, obviously you got to get it to a point where it can compile, and then you can test that. But once you can say like, okay, I've got another way to say it is, let's say you pass test number 1. You coded it for test number 1, and it passes test number 1, but not number 2. Code it for test number 2, and then make sure that passes before you try test number 3. Does that help?
Yeah.
Obviously, as I mentioned before, debug often. The wrong way is just run it, see does this work or does it not work. I show this every semester and I love it. Let me see if I can find it again. There's a wonderful movie, one of the great masterpieces of cinema, Weird Al's UHF. I think it's on Netflix. I've never heard anybody watch the movie and regret it. If you're bored, throw it on there, you'll enjoy it. There's this little passing scene that just cracks me up. So what's going on here?
He's testing all of his code.
A blind person's trying to solve a Rubik's Cube. And how is he trying to solve it? He makes us turn, shows it to the homeless person, and asks, does this work? And the guy says, no. This is how many of you program. You are like the blind person, not understanding. No. Which one of these is there? You are like the blind person. A lot of you are, not thinking about what you're doing, and you just make some tweak. And then you run the program and see, does the output work? So the Rubik's Cube would be like your program, and the console message in the unit test would be like this homeless person saying yes or no. We've all been there. It doesn't work. Maybe for really small problems where you only have a few combinations. Yeah, eventually that's going to get the problem done, but for this class it can't work. And far too many of you are just, I call it Rubik's Cubing your program. You're just, oh, is this it? Is this it? Is this it? Is this it? I give up. It didn't work. No, you got to think your way through these things. So debug often. I don't want to keep lecturing on this forever. You don't know the other ones. I hit it. Don't give up. Everybody gets confused. What other ones do you guys do that you think is important for others to know? Problem-solving approaches.
Make sure you
Spell things correctly. Think like a compiler. I would say write clean code. There's a very high correlation between people who don't tab their coding correctly and people who can't figure out their program.
Oh, I like it.
If your program doesn't look pretty, chances are you're sloppy. I'm not saying this is a perfect relationship, but chances are if your program is sloppy, your logic is sloppy. If you take the time to make your program clean, you'll think about it. You'll also write clean code as well. And I say this, I remember, it's a loose analogy, but I've tutored math before. And I remember one poor girl that I tutored for years. I tried to explain to her there's a 5-step process to solving problems, and every single time for years and years, I couldn't get through to her. She just wanted to read the problem, the story problem, and just throw out a bunch of numbers on the paper and just do some random operations on it and then circle it and not even think and then move on. And I don't know how you can exist in that state. I'm the opposite. I write an answer and I'm always just thinking, is that right? Are they going to put that up on the projector and mock me? Is this going to be circulated around faculty meetings where I'm laughed at? I have to make sure this thing is right. What does this answer mean? Is this... The last 5 answers were odd. That's a strange coincidence. Paranoia is actually a really good strategy. If we could instill one mental illness in this class, I want it to be severe paranoia because it would be effective. That's right. He's one of my proteges. He's got the paranoia starting up. All right. Sorry about that. Let's get back to programming here. So we've got doubly linked lists. I believe I posted the file for you in the pages section. If you want to continue on with me, you can. What we covered was insert last, insert first, delete last. Because these are doubly linked lists, we saw that these were largely mirror images of each other. And we also used shared pointers. Tell me what you remember about shared pointers. I want to see if I should be fired from my job. Tell me everything you remember. What's
No more delete. That's what he said.
No more delete. What else?
Keep track of the instances that use them.
Internally ref counts. Reference counts, well, I'll just short it to ref counts. Good. You do need a library. You don't use the new keyword. What do you use instead of new? What was it?
Make sure.
Use make shared. All right? Yeah, Shared pointers, what makes them shared is you might have several pointers with different names, but really they're just the same thing. You can think of it that way. It's a fine analogy. I like your joke, Jeremy. One more that I want to go over. Well, can you ask the shared pointer how many instances are being shared? You can. How do you let go, or how do you actually say I want this thing to delete? Can you, or how do you set it to null pointer? It was reset.
Yeah.
So don't set it to null pointer. Just use reset. So use reset instead of equals null pointer. Assign null pointer. Any others? Is there anything else you're confused on? Now, as we talked about, they're not always a perfect solution. If you have arrays, there's a little more syntax involved. If you have things that refer to each other, and a doubly linked list is a great example. You can't just delete the linked list object and expect all the nodes to clean up. So you still have to manage them somewhat. It's not like it's just free memory garbage cleanup for you. All right, so let's cover. Did we do the destructor yet? We did not. What do you want to cover? Delete in the middle or the destructor? Choose your own venture. Nobody cares. I'd rather have a real epic journey. Delete in the middle. 2 votes for that. All right, let's cover it. Do you want to do delete by a value in the middle or delete at an index? All right, let's do delete by a value. So we will say delete matching. Void delete, I'll just call it delete matching for short. This is going to be delete first instance of node with matching data. But I'm not a fan of method names that are that long. So I will copy that method name so I don't have to worry about typing it wrong. Let's do this. Void, it belongs to the doubly linked list. Whoops, I'm in the wrong section. Const T reference item. And I'm editing the file that's not part of my project. I want to stick this in my project. There we go. That way I get my IntelliSense. So our goal is going to be find the node and then delete the node. Finding the node, we can proceed using a cur and just looking down the list until the data matches. Now remember, we're trying to completely avoid, I gotta add one more to my list here of shared pointers. Avoid mixing regular pointers and shared pointers. If you're doing shared for some, do shared for all. Don't try to be sneaky and be smart. So we're going to make a shared pointer. Where's our syntax for it? There it is. So I need a shared pointer which points to node objects, and I will call this guy cur. And he could equal first. Finding the node we can do with a while loop. While cur. We'll have to do two things here. One, is there data to be used here? And two, how do I put it? Have we hit the end of the list? Or does the data match? We have to ask both questions. So how do you ask if cur is at the end of the list? Normally we would have asked if cur doesn't equal null pointer. Keep going. But do we really have the idea of a null pointer and shared pointers? No. So what's the analog of null pointer here with shared pointers? Not ref count, not reset. Is there a way to ask, is it empty? Remember that? It overloaded it for us.
Is this better than just doing it based on count?
Yeah. So I'm going to ask while cur, because that will actually invoke, I know it sounds kind of funny to say it on its own, but that will invoke the Boolean check to say, is that pointer actually pointing to something valid? Make sense? I should throw this in the avoid using null pointer. Correct? Instead, just use the overloaded operators to check if the pointer is useful. So while cur is a useful pointer, and cur's data doesn't equal item. How do I iterate a pointer ahead of node? Not cur plus plus, what is it?
Cur equals cur arrow forward?
I don't know, I have forward link. Is it? Oh, because the IntelliSense doesn't know yet. Yeah, we're going to do cur forward. I didn't see the IntelliSense, and my hunch is because it's a shared pointer of nodes, not just a regular node. So the IntelliSense didn't quite get that figured out yet. All right, this is really important, and this is a neat topic I want to go over. If I write my while loop that way, it works. If I wrote my while loop this way, it crashes. Why? Don't you look at that and say, well, that's asking if A and B, and this is asking if B and A. Isn't that how Boolean logic works? You can oh, what's the math rule of you can flip the, is it commutative? Is it associative? What's that? Is it associative? Some property which everyone has been told you have to know about, but we all forget. You know what I'm saying, right? Yeah. In your head, you're thinking A and B, and this looks like B and A. And everything you know about Boolean is like, well, it doesn't matter the order, correct? It turns out in computer science, the order does matter. Let me show you why. There is something called short-circuiting, which says, if this is false, is there any need to check the second half? Why? What's false and false? False. What is false and true? False. No matter what, false in anything is still false. What is false in maybe? False. What is false in I don't care? False. It doesn't matter. You start with false, it'll be false. And so you check to see if current is even a useful pointer. And if it's not a useful pointer, if it's false, what will the code, will C++ even run that second part? No, it won't. It will just drop out of the while loop. Oh, well, the thing's gonna be false. Why bother spending more cycles computing the second part? Let's just bail out of the while loop. That's really helpful for us. Because look what happens if we try it the alternate way. What if cur is not pointing to any valid spot, the equivalent of null pointer? Can I dereference a null pointer? Do I need to pull up that one wrestler pointing to his computer again?
Yes.
Here's your problem. You're dereferencing a null pointer. That will crash it. So this, if we check to find the data, but the cur wasn't even a valid pointer, it will crash. And then we do our check if cur is even valid. So if we do it in this order, it's almost like we're asking a little mini if statement on the inside. And short circuiting is great for that. If cur is valid, then if cur's data doesn't equal item. We're saying all that inside this while loop up here. So I will keep the while loop as is. Questions on that? Or also can be short-circuited. If the first thing is true, does it matter what the second thing is on an or? True or false? Still true. True or true? Still true. So this loops cur forward, getting to the node we hope. Now it's possible, we do have to do one more check. If cur, how about this? If not cur, we can say a message. Cout node not found. Just to do a quick bailout, the node didn't exist. We get out of the while loop, it's possible that cur isn't pointing to a node that's useful, so verify that. Else, let's do a return here. Now we can do delete the node. Now it gets fun. Again, we have all our scenarios. Specific to general. What's a good specific scenario I should cover first? One node. What's the next scenario we want to cover? It's the first node. What's another scenario? Last node. And what's the scenario we want to solve first, but we really should do it at the end? Middle. All right, how do I do the one node scenario? How do I check for that? If what? Without using count. If. What was that? Nope, we already checked for that. How do I know if it's a one node list? First online student to answer the question passes the class and you don't have to come back. Oh, Chris already answered before I made my promise. Offer is rescinded. If first equals last, that must be delete, or that's the one node scenario. Getting rid of this is as simple as saying let's delete. Here we have first, cur, and last all pointing to the same node. So whatever one I get delete doesn't matter. How about I just do delete first? And how do I ensure that I let go of the node? Remember, first is pointing to it, last is pointing to it, and cur is pointing to it. I got to make sure the node. How do I wait? Do I actually want to delete first? No. I'm not a shared pointer programmer. Should I use the word delete in a shared pointer context? Doesn't that just violate one of my rules? Did I not write it? I did not write it. Oh, there we go. It's the most important rule. You shouldn't be writing your own delete. If you ever have the delete keyword, you're doing it wrong. We'll let cur go away on its own, but how do I have first and last give up their point? How do I make sure that first and last give up? Is it release or reset? First dot reset, last dot reset. That means first and last have basically given up pointing at that node. Cur is still pointing at it, but what will happen when cur goes out of scope? it'll go away too. If you really wanted to, I suppose we could say cur.reset here, because that would then, it's a little more explicit that, yeah, at this point, all of the pointers have given up, and now the node will delete. I kind of like it that way. Do you like it that way? Yeah, here I'm going more for code readability than saving one clock cycle. And once we're done, I could do a quick return, or I could just, I'll do this as a bunch of else ifs. So we're going to have an else if for the first node scenario. We're going to have an else if for the last node. It's all written out here. Else for the middle node. There. That's a good clean setup. I like that structure. We should do a count minus minus. We can do a count minus minus right here. Jeff, you got it. Manny. Everyone okay so far? This is kind of nice. I've actually never programmed deeply with shared pointers, so I feel like a student. Like, I look at this code like, I don't know if this is right. It feels new and weird. This is how you must feel every time you do homework assignments.
Sometimes during lecture too.
All right, how do I delete a first node? We know there's at least 2 nodes. What can I do to have it get rid of the first node? Any ideas? Do I need to draw it out? Let's draw it. We will do, oh yeah, you're right, Jeremy. We could just use the existing delete first. It's not a bad idea. Should we just reuse code? I guess we should. It's probably good programming. This delete first. Now I don't have to say this arrow, I'm just kind of being explicit which one I'm calling. But I didn't do anything here in the else if to verify is it the first node scenario. How do I check if it's first node? If what? Remember, cur is the thing that we have to work with. If cur equals first. Now, Jeremy, I've been installing paranoia into your head, and that's good. I think there's a bug. Let's go look at delete first if we're paranoid. What will delete first actually do? This is the equivalent of constantly checking if your car is locked. Did I really lock it? Was that beep mine or somebody else next to me? So what does delete first do? It does have an empty list scenario. It does have a one or more node scenario. What's the bug? We're going to decrement twice. If you call delete first, it does your count minus minus for you. Paranoia helped us out. So let's do this. If we write our own code, we will do our own count minus minus. If we call a method, we'll assume that method does count minus minus for us. Does that sound all right? If you really wanted to be cleaner on this, you could even say, you know what, our delete first handles the one node scenario. So I could actually just get rid of all that. Right? I don't see why not. There's a, it's a philosophy that another code group uses. See if I can say it right. Code not written is code not debugged. In other words, the more code you write, the more code you're going to have to debug anyways. If you can do the same thing in fewer lines of code, that's less debugging you have to do. All right, let's get rid of some lines of code. Hopefully we don't have to debug that. All right, so what should I do? How do I check if it's a last node scenario? If what? I'll add a first node and one node here. Else if cur is equal to last, we are at the last node scenario. And what should I do here? Call our, delete last. No, we'll keep it simpler than that, Jeremy. Else, and now at this point, I'm sure a lot of you are just wanting to do delete middle because it follows the pattern. No, we have to manually do this one. It's not bad. Let's go ahead and draw out a few nodes. Get 5 nodes on here. We'll have our linked list in here. Get a null over here. Suppose our cur is right there. How do I pull off getting rid of that node while I update the list? Do I need a prev? No, I can go back to the node behind it. All right, picture-wise, tell me what I need to do. Anybody? Move the current just to here? No, that doesn't delete the node. Our goal is to get rid of this guy. This node has to die. Chris uses prev, but we don't have a prev. Jeremy says make a temp node, which is almost always a good idea. It might be overkill, but it seems to solve things a lot. Brandon says cur's back is equal to cur's forward. So here's currents backward. And if you say currents backward equals currents forward, you have just done that. Which doesn't really help us. You know, I can't really say forget. I should say, or die, I should call it forget.
So
That's the whole point of SharePoint. We need to forget, so it dies. It's like the poor popular girl in high school. Poor popular person. Thrives on attention. The way you kill them, you don't actually do it. You just get everyone to ignore them. Actually, that's a really morbid one. We shouldn't go down that road.
It's like someone was spiteful of nice.
Yeah, no. That analogy just didn't work out at all.
Wow.
What would be a better one? Starving internet trolls. There we
There
go.
you go.
That's it. If someone's on the internet's being an obnoxious twat, what's the best way to stop them? Do you actually engage them head on? And no, that's how you get them to be even more obnoxious. What's the way you stop them? You just ignore them. And they just go away.
okay, so
So it goes away. This will be our... There. Now I won't get in trouble. So actually, Jeremy has an idea. Jeremy says curs forwards back equals curs back. He's chaining up method calls. Is that where you were going to go down?
Yeah, I was gonna say, can we do curs? Yeah, back to that forward. Going
Yeah.
to-
So Jeremy's got it written out.
Yeah.
So if I say curs forward back, what's that referring to? Well, here's curs forward, here's curs forwards back. The highlighted region is cur arrow forward, arrow backward. Do you see that? This one says go to, this one says go to, this one says the actual thing. So curs forward backward is that red pointer. And what do we want to set that address to? The same address as this guy, correct? So curs forward backward we set equal to curs backward. Now it points here. Is that
Good job, Jeremy.
getting to our goal? Now what should we do? Are we done yet? Have we properly forgotten about that node? We still have this guy. Someone's still engaging the internet troll. No. How do we get rid of this link? Curs backward forward is equal to what? So let's do this. Curs backward forward is this thing right here. Correct? Curs backward forward is equal to what? Curs forward. No, Mike, I kind of almost want him to avoid this part of the lecture so I don't get in trouble. Now we could do a participation code. What would be some good numbers? Yell out a bunch of numbers.
Someone wanted to try before, didn't they?
What was that?
Didn't someone last time want to try?
Well, we didn't do that yet, did we? We've 1, 4, 1, 5, 9. So here's our nice participation code. All right. Have we properly forgotten about the node we wish to delete? Yes or no? Why? What's still pointing to it? Cur is. So how can we can either let cur go away on its own, or we can be a little more explicit and just say cur.reset. I think I like the cur.reset. It's cleaner to other people. So what was our code that we need to do here? Curs what? Curs forward backward is equal to curs backward. We also have curs backward forward is equal to curs forward. And then we will say cur.reset to this now deletes the node. And then I can say count minus minus. Jeremy, a common solution I see people do on these homework assignments, and this is an alternate approach I've seen to delete all instances. you can write a private method, not a public, but a private, and just call it delete node, where you take in a pointer. So for your homework assignment, you would do it this way. You would do a node pointer prev, node pointer cur. And let this method say if I've got a prev and a cur, I will just delete the cur and update it as necessary. Does that make sense? The other thing you have to remember is if you're updating prev and cur, this looks a bit weird, but you have to do it. You also have to do these things by reference. Pointers by reference kind of mess with your heads. But the idea is that you're updating the address of those pointers. Cur is now going to point somewhere else. If we update cur, we have to make sure that whatever we update gets passed back. So the great part about if you write your own delete node, you can put all your scenarios in there. One node, first, last, middle. And then you make your while loop a heck of a lot easier for delete all instances. While it matches. Okay, delete node. That's it. In this method, we would have had a delete node where I have to pass in a shared pointer of node t by reference. And I would just call this guy cur. So if I were to write my own delete node, now my delete node will have all my scenarios in it. And that would mean that here, instead of having to write 3 different scenarios, I would just simply do delete node cur. And all of that would go into my delete node method. Whatever way you pick for your assignments, it's up to you. Definitely keep these as private. You obviously don't want anything dealing with pointers to be seen by the users, by people calling your methods. Other questions so far? We should check to see if our, I've done my, I violated my rule. I didn't check my code. Because I'm a great programmer. All right, so we're going to get rid of all my delete first. We're not using an index parameter. We're deleting by matching value, not by an index. So we're going to try right here. My list dot delete matching. We're going to kill Sauron because the books say that's a very easy thing to do. It's a 2-page pamphlet. I will debug it. I don't know why, I'm just absolutely paranoid of just letting my code run start to finish. I have to watch it process the first time. Step in. Oh, I went into the string constructor. Step out. Let's go back in. There we go. Step over. We'll find the node. It's not the first node. It is the second node. Good. Sauron was a second node. Second node does exist. It's not the first. It's not the last. It is in the middle. So we update cur. So now we have cur still as pointing to Sauron, but if I go look at my first, let's go mouse over and take a look at first here. First has, these are shared pointers, so it takes a little longer to get to it. Snowball, who points to Waffles, who points to Corgi, who doesn't point anywhere else. Was Sauron removed from there? Sauron was a second in the list between Snowball and Waffles. Sauron is now gone. Because it's a doubly linked list, I will look backwards. So Corgi points back to Waffles, who points back to Snowball, who doesn't point back to anybody else. So we've gone forwards, we've gone backwards. This should get rid of the node Sauron. I don't have any way to check that here, but I just know that that's what shared pointers do. We decrement our count, and we are good. Sauron has been removed. That'd be a great way in the Lord of the Rings. Instead of actually killing Sauron, everyone just kind of forgets about him. What power do you have if nobody worships you? Ah, my secret flaw. So we have a delete matching that functions correctly. Again, please do not try to copy and paste this code for your singly linked list. You need a prev and a cur. It's a different strategy. All right, we have the destructor we got to write. We did copy and paste a lot of our code over from before. Let's comment this back in and look at it and see what modifications we need to make. Does line 44 look good, or should we update it for shared pointers? How? No. It's actually going to be while first. While first is still a valid node. Okay, that's been updated. Line 45, should this get updated? Well, hold on. I'm jumping ahead. What is this? We do need to update this. Let's update it right now, and then we can ask what the code's actually doing. So how would I update this for shared pointers? Shared pointer of node t. Don't have to say pointer anymore. Temp is equal to first. Good. Should I update line 46? First equals first link. How should that be updated? First forward. All right, line 47. Should I say delete temp? No, we don't delete. Now here's where we're trying to ask you what. You could say temp.reset, but now we need to stop and ask, what's the purpose of the destructor? To get rid of all the nodes, correct? Before we were trying to manually get rid of them. Let's ask, does this actually do this in a shared pointer context? That set makes a temp. Let's draw it out here. I'm going to update. Get back to where we were. So we have a first, we have a last, we have a temp. This is what our destructor has done. Then it says first is equal to first forward. Correct? And if I say temp reset, does that actually clean up the node? Why? The next one's back pointer still points to it, correct? So what should I do here?
First backward reset.
Can you reset? I bet you can reset a pointer. You're saying before you even move it, let's forget all the things behind it, correct?
Yeah.
You want to just say first backward reset every time, then move first ahead, first backward reset. Can you reset an empty shared pointer? Does that make sense? If this guy's already empty, can you reset it? I would assume you can, but we should look that up. Can you reset an empty shared pointer? Come on, Stack Overflow. Yes, I knew you would be here. Oh no, we've already been there. Can we call set on a null shared pointer? Can we do this? Yes, but it's still a valid shared pointer. Basically, shared pointers and all. You know what? Let's just try it. I'm pretty sure it'll work. It would be weird for me to see that they wouldn't support that situation. So you're saying while it's a node, you're saying first backward dot reset.
Yeah.
I like that. Then do I need to worry about making a temp? No, the whole point before with temp is to keep track of a node so we can manually delete it. Do I need to keep track of it to manually delete it? No. So let's get rid of this temp, and let's get rid of that temp reset. And then we're going to say first equals first forward. Right? So if I say temp backward reset, I don't have a temp, and I move first forward, then what this will do is it will say, the code will loop again and say first backward reset. Does that help us get rid of this node? It actually does, because is anybody pointing to it? No. I thought it was going to be harder than that. It's a good thing we drew it out. No one is remembering that first node anymore, so it should clean itself up. So this goes away. And then we do first equals first forward. Let's just see it through again. All right, so first is equal to first forward. Good. Then we ask ourselves, is first a valid node? If so, first backward reset. Does that get rid of this previous node back here? It does. All right, always check your scenarios. Let's get first up to this point. Suppose we are now at here. This previous node went away. We let the we do first is equal to first forward. Okay, first goes ahead a slot. We then let it loop around. Is first still a valid node, a pointer? Yes. Okay, first backward reset. Get rid of this guy, which then makes this guy disappear. Correct? And then we say first is equal to first forward. Correct? What is first forward? It's basically an empty node, so this will make this guy empty. And then it means it doesn't loop anymore. Does that clean out that last node? Why?
Still pointing to the last.
Who's still pointing? Who's still remembering that last node? The last pointer. So we need to do one more trick here. Last is last dot reset. Boy, that's clean code. Compared to our destructor before. I mean, our destructor before was clean, but this is really clean. I like it. I don't have anything in here in this code to verify if I have any memory leaks. So you know what I'm going to do? I'm going to put a simple message. Oh, I do have one. No destructor invoked. I want to count how many times that happens. All right, so I know that no destructor invoked should trigger. Here's how I'm going to do this. I'm going to put all of these inside of scope braces just to watch it. Sound fair? I know a no destructor should trigger once after I run that line of code to get rid of Sauron, correct? And then after it closes the curly brace, it should fire off the destructor, and then we should see 3 more no destructors invoked. That will be our test. Hope this works. Please, 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 please. There's one. Good. That's what we were expecting. Now we're expecting 3 more, correct? Take a look. Yes! It did it. Automatically cleaned it up. We're good. We have our destructor. How's everyone doing? Last time I covered shared pointers, you said it was overwhelming. Does today feel just as overwhelming as Wednesday? Getting easier? Not too bad. All right. Good, because now I can throw a new topic at you. Iterators. These are near universal in programming languages. Their main concept is that they are, let's call them smart pointers, not shared pointers. We're going to call these guys smart pointers. I'm going to put it in quotes because they're not really pointers. Smart pointers that point to some entry in a container. Now I'm keeping this generalized because iterators have very generalized purposes. So far we've only worked with our containers of an array, especially a 1D array, and we've worked with linked lists. Is it possible there could be more containers than that? Yes. For example, a common one that I had to work with is a 3D array of cells. And the idea is that we need to do some math on these cells so that for every cell we needed to update its values depending on whatever the physics of the problem were. Internally, this was a 3D array. And it was very annoying for people to say, if I'm here, then do memory looping or keep track of the strides where the pointer is, update the address this much, go to the spot in it. How do I put it? We wanted just to immediately jump to the data. We didn't want to have to do 3D indexing on it. And we didn't want the user to have to figure out how to do that, jumping around to the data. So what we did is we created iterators for them. And the idea of these iterators is they're these little objects. They're called smart pointers, which keeps track of some spot in the container. And you know what you can do to iterators? You can say go to the next item or go back an item. And here's the beauty of it. You say go to the next, go to the next, go to the next, go to the next. What if you're at the end of that row and you say go to the next? What does it do? It figures out how to wrap around. What if you're right here? It knows to go back a slice and then start back up at the top. So internally, that iterator was aware of the structure of that container and moved it around for you, so you didn't have to worry about the details. Does that make sense? There are things such as vectors. There's a C++ vector. There's a queue. There's stacks. There's something called hash tables. There's all sorts of different kinds of containers, and there might be a data set from an SQL query. There's all sorts of container. A container is any kind of class or any kind of object that inside contains lots of items. So it's not just holding one item, it's holding one or more items. Make sense? And we want a simple, straightforward, universal syntax so that you can say, you have a container. I don't care how complicated your container is on the inside. All I care about is getting my data and going to the next data and going to the previous data. Just give me that much. In fact, you often don't even need to go back. You just give me my data and go to the next data. As long as I can ask those questions, that's all I want. I'll let you worry about how it's structured. Makes sense so far? Let me give you an example of why this is nice. I'm going to save this guy. So let's save this file so I can post it. Doubly linked list day 2. I'll actually put this as part of the I'll do these iterators as part of this for now. But for now, we're going to include vector and list. This is the STL's vector and the STL's linked list. So I will need to do a using std list and using std vector. So we're going to use 2 containers given to us through the STL. And I'm going to load it up with data. STL is a standard template library. Most all C++ environments give you access to some standard template library so that it's easier for you to program. You got all the set of tools to go with your C++. So let's comment this out for now. Let's make a list. So list. Let's do list of strings again. I need more pet names. So I'm going to say my list dot, and to stick stuff into, just to save on time, I'll just put in a bunch of numbers. My list of ints. For int I equals 0, I is less than 10, I plus plus, and I'm going to push in back all the squares of the numbers. So my list dot, and I have to say push back to load it up, and it will be I times I. That's like my insert last. Sound fair? Now I'm going to ask you guys, tell me how to write code to display everything in the list. This is the STL linked list. What would you do? What would you do to tell me the code you would write so I can display all 10 numbers that are in that list? What should I do? Tell me code. If I gave this to you as right now as a big pop quiz. All right, the STL list has 10 items in it. Show me all 10 items. Make them all display on screen.
Are you talking like it already has something written?
No, you tell me. If you were given some container, how would you go about, what would you start typing just to show me? Chris says let's do it as a for loop. All right, for what? For what? For int I equals 0 to the size of the container. Is there a size on this container?
Could you use dot size?
There is a size. Okay. Now how do I go and get some item in the list? My list dot, do you want to look at all the methods? You want to do like a get at index, correct? Okay, let's do this. These IntelliSense isn't clear. Let's actually go take a look at C++ list. C++.com is the easiest for us to work with. All right, so we're looking for anything that lets us access elements. We're not trying to modify elements. We're just trying to access. What tools does it give us to access stuff in the container? Front and back. Does it give us anything to access it in the middle? No. So how do we get stuff in the middle? What's the point of a list if they don't let us get to the stuff in the middle? So I've heard this as an approach before. Well, let's make another list, and as we will pop off stuff off the first one and push it on the second one, and as we do that, we'll display it. And then when we're done, we'll recreate the list by popping off the second and pushing back onto the first. Does that seem like a good idea? No. So there isn't any kind of, there's front and back. We could do my list, cout my list dot front, and then my list dot pop front. And this will work, but then it kills the list. Right? not very useful. Let's do something easier. Vectors. Vector of int, my vector. For int I equals 0, I is less than 10, I plus plus. My vector dot, is there a pushback on vectors? There is. Pushback I times I. All right, how do I go through and look at all items of vector? Maybe this is easier. Cout my vector dot. Let's go take a look and see what we got for vector. C++ vector. We are looking for anything that lets us get data. Element access. Do we have more options this time? Yes, we can do front and back, but we have more. We can go to the operator square brackets. Ooh, that's nice. There's at, which is basically almost the same as operator square brackets. There's a new one that I don't know about. Access data. That sounds pretty generic. What does that do? Returns a direct pointer to the memory array used internally by the vector. Oh. Vectors are wrapped arrays. And if you want to get the pointer to the array, you can just ask for its data and it gives you the array. They expose that now. But we're going to use operator square brackets. It looks to be the easiest. How about we do my vector at I? Sound fair? All right, I'm going to run the code. I should see 014916 014916. Why did that one only go to 5? This one did 10, that one did 5. I am confused. Oh, I know what. Wait. I know why. No, I don't know why. This my list.size should be 10. Front. Does the front actually both get and remove it? No, because it only went to 140. We weren't skipping every other. I'm absolutely baffled here. 014916. Oh, you got it, Brandon. Size decreases with every pop. If I call pop front 5 times, what will the size be? 5. So it stops. So to fix that, we will want to say, because we're modifying a good rule of thumb, never modify a container while in a for loop. Causes all sorts of problems. So we're going to actually just make a size. And I'm just going to stick the size right there. There we go. That should do it. Ah, we got him. All right, was that annoying to have to come up with 2 completely different ways to traverse two very straightforward containers? Yes, what if you have a third kind of container? You want to have to learn how that container works. No, it gets really obnoxious anytime you get some new data container to say, how do I use you? Sometimes you just say, I don't care. I have to deal with dozens of containers. Just give me iterators. So we're going to do iterators to show you the easier way. So let's comment out this garbage. And let's show you the iterator way. There's an old way of iterators, and I'll show that to you because it's crucial you understand what's going on. We'll still use a for loop, but I'm going to make some kind of smart pointer that points to the beginning of the list. It's a long declaration. Inside the list class is something called a const iterator. And I will call this guy iter. And I will ask the list to tell me where that begin iterator is. So we're asking the container, hey container, tell me where your first item is. It says, all right, here you go. Here's an iterator object. It's like a smart pointer. All right? I want to keep looping as long as my iter doesn't match the end iterator. Hey, linked list, tell me where your end is. As long as my pointer, my smart pointer, doesn't match the end, I want to move my smart pointer forward. Now I want to see what's there. Now that's a mess of syntax. First time I saw it, I hated it. It has purpose, there's reason behind all of it, but I don't expect you just to soak it all in and know it right now. Just know the general idea. Make a little smart pointer at the beginning of the list. Every time it loops, move the smart pointer to the next item, the next node. Keep looping as long as we haven't hit the end. Since we're making this guy act like a smart pointer, let's act like we can also dereference the pointer and get the data at that pointer. Sound fair? Does that work? It did work. We got all our data. Further, did I actually destroy the list this time around? No, I wasn't popping. I didn't even have to worry about saying anything about size. I just let it say, keep going until you hit the end. All right? Let's do the same thing with vectors. We're not going to do it the manual way. Let's do it the iterator way. For vector of int, const iterator, iter equals my vector dot begin. We want to keep going until this iterator hits the end of the vector. And every time we loop, we want to move this vector iterator forward a spot. All right, now that I've got my iterator, I want to go to the data that this iterator points to. So I will say cout iter star iter. What do you notice about that loop for iterator for list and that loop for iterator for vectors? Is it the same idea? Yes, this is the key thing about iterators. Different containers, who cares? Vector iterator syntax stays the same. So what if I throw in a third or fourth or fifth kind of container? What should we expect? Exact same syntax. So then you go, okay, yeah, that syntax is messy, but at least it stays consistent. Oh, but wait, there's more. The C++11 folks said, you know what? That's ugly. We really don't need to make them say all that every single time if we can just infer it. So here's how they cleaned it up. For every int item in my list, cout the item. Because here's what's that's it. Because here's what's happening. They say, well, okay, well, if you try to use this syntax, if you just throw a colon in there, you're saying for everything, every item in that container, all right, well, does my list support iterators? Check. Does that iterator support begin and end? Check. Do the iterator support not equals? Check. Do they support plus plus? Check. Do they support dereferencing? Check. Oh, well, they do those things already, so why do I make the programmer do it when I, the compiler, can just turn this code into that code? Yes, a lot of languages have moved to this syntax, but behind the scenes, iterators are what pulls it off. And that's crucial because I'm going to make you write your own iterators. So you have to understand what's happening so you know that this can automatically or auto-magically work. Right? So how would I update my vector? What should I do this to do it the new way? For int item in what? In my vector. And what do I do here? If you want to go a step further, you could even say auto here. Because it will even figure out, well, I know what this is. My list holds ints, so item has to be ints. So you don't even have to say the data type. You can just say auto there.
This is ridiculous. It's awesome.
Yeah, it can infer the data type. It's not like it guesses. It knows. My list, it's a template. It's a template of ints. Therefore, it has to know what item is. It has to be ints. Do you like that? Let's make sure it still works. It'd be a fun lie to tell you guys. That'd be like one of my evil end of lectures. Like, check out this awesome new syntax. By the way, that syntax doesn't exist. You go to do your assignment. Now, oh, I can't use that syntax. It doesn't exist. Yep, it did work. Let's go show you. 1 through 81's. Why is it doing it 3 times? Did I not I didn't comment this one out. There we go. There we go. It's working. So another thing that might come in handy for you, this grabs the data by value, so I think it makes a copy. That will do it by reference. So if you ever want to update the data, you can. I haven't messed with that a lot, but I believe that's the way to do it. It gives you a little bit more features here. Let's go ahead and end here. We'll talk about how to write our own vectors next time. Just as a heads up, in order to support vectors, there's 5 things you have to cover. You have to make, for the container needs a begin and end method that returns iterators, and you have to make an iterator class which supports not equals. It has to support ++ prefix, and it has to support star for dereference. You supply those 5 things, iterators will then suddenly and magically work. And there's all sorts of powerful things we can do with iterators. We haven't scratched the surface of them yet. Any other questions for me? All right, I'll have a quiz out the door. You have an assignment due Wednesday. There was a participation code given out earlier. That's just for the normal points for the lecture. It was an irrational number, but we capped it at 6. However, if you do figure out the correct amount of I'll put in a second one, where if you figure out the correct amount of irrational numbers, keep trying until you get it, you will have enough